everyone. Welcome to our February JSC webinar. My name is Michelle Everson. I'm the current editor of JSC, and I'm excited today to welcome two speakers. I'll introduce them in a moment, but I first wanted to just tell you a little bit about how our webinars work. Our presenters will present for about 15 to 20 minutes, and then we'll open things up for questions. Along the way, as they're talking, if you have any questions, there is a questions room, and you can type your questions in there, and then I'll be sure to ask the questions of our presenters toward the end. So I'm really happy to introduce Kendra Schmid and Erin Blankenship, and they're going to be talking today about a paper that was published in our November 2014 issue of JSC called The Development and Evolution of an Introductory Statistics Course for In-Service Middle-Level Mathematics Teachers. Go ahead, Kendra and Erin.
Okay, thank you very much, Michelle. I'd just like to say first that this paper was really a joint effort between myself and all of the other authors. So Erin was the lead instructor of this course when it was first developed, and through several iterations. Some of the other authors and I were actually graduate teaching assistants at the beginning of this, and then Wendy Smith is very involved in the Math in the Middle program, which I'll talk about just briefly. So first we'll just give a brief introduction to what's called the Math in the Middle Institute, and that's what this course was a part of. Then we'll talk more about the course itself, the Statistics for Middle-Level Teachers, talking about the goals of the course and how it's evolved through several iterations, some other more practical things like the assessment and grading, and examples of some lesson plans, and where we are now with the course and how it's been sustained from its initial offering. So the Math in the Middle Institute was an NSF-funded program. It's a 36 credit hour degree program for in-service middle-level math teachers, and it has a competitive selection process for each of the cohorts. The goals of the program are for teachers to build strong mathematics and content knowledge, study and practice the art of pedagogy, develop the ability to conduct action research about their teaching practices, to cultivate leadership skills, and to apply their knowledge and skills in the classroom, and to ultimately become leaders in their schools and districts. Here you can see the different courses that the teachers have to take as a part of this master's degree program. So they're taking some higher level mathematics classes. They're also taking some different education classes. You can see ours, the Stat 892 Statistics for Middle Level Teachers is the only stat class in there. And then they also have a class where they do a research project at the end.
So we had four main goals for the course when we were initially approached about developing it and teaching it for the first time. The first was obviously to help the teachers better understand the statistical concepts that they would be teaching, the statistical concepts that are actually in the middle school curriculum, and how better to relay these ideas to their students. But we also thought it was really important that the teachers understand the content at a higher level and at a deeper level than they would expect their students to. So we also wanted to help them improve their statistical reasoning and thinking, both about the statistics content in the middle level curriculum, but also beyond that. So they would have a good picture of where their students were coming from, but also where they were headed with a little bit higher level statistics when they got to high school. We also wanted to help teachers understand the statistical information on their students and in educational research. They read quite a bit of educational research as part of their master's program, and so we wanted them to be able to really understand the statistics that was present in that research. We also wanted them to understand the information they were getting back on their students from things like standardized tests. And finally, as Kendra mentioned, the teachers would have to do an action research project, and we wanted to prepare them quantitatively for the data they would be collecting on their own students. So, Kendra, you can go on to the next slide. Okay, so when we first offered this course the first time, it was nearly 10 years ago at this point, and this was pre-GAZE, pre-Common Core, and we really emphasized, I think, calculation quite a bit. Our initial plan, the course played out over 1 week, 8 hours a day. And initially, you can see what we had planned for the 5 days. First day, we were going to do graphical measures of data, measures of center and spread, move on to bivariate data on day 2 with simple linear regression and two-way tables, also talk about sampling and experimental design. Those 2 first days went pretty well. We actually ran them as we had initially planned. The teachers had experience with those topics. A lot of them commented that they already taught things like stem and leaf plots in their courses. On day 3, however, we really hit a wall. Day 3 was the day we had intended to do elementary probability, random variables, and sampling distributions. And the teachers really, really struggled with this, particularly with the sampling distributions. And so at that point on day 3, we really had to kind of refocus the course a bit. We had planned to do confidence intervals and hypothesis testing for 1 and 2 samples on day 4 and kind of synthesize a lot of stuff on day 5. What turned out happened is that we spent a lot of day 4 still on sampling distributions. We tried to build them up empirically rather than talk about theoretical sampling distributions. We did do confidence intervals and hypothesis tests, kind of the introduction to those things and p-values on day 4, and we focused on interpretation rather than calculation. So part of the Math in the Middle program, the teachers all had TI 84s, so we relied very heavily on the calculator and then just talked about the interpretation of the output from the calculator. We were not able to really synthesize the topics like we wanted on day 5. Instead, we ended up doing 1 and 2 sample inference. This was in Cohort 1. We adjusted this for later groups because we thought it was so important that we actually get to synthesize and do more data analysis. As Kendra mentioned, this course has been taught a lot. This was our first offering for Cohort 1, which was in 2005. I think the next slide sort of gives what changes we saw across the different cohorts. So Cohort 1, we had them 5 days a week, or 5 days from 8 to 5. It was a really traditional format. We focused a lot on mechanics and calculation. I think if any one of us had to go back and do this again, we would not do it at all the way we did the first time around. Cohort 2 didn't go much better, but I really think that Cohort 2 was because we had them for 2 days live in person in Lincoln from 8 to 5, and those first 2 days are the ones the teachers really understood anyway, focused on content that was already already taught in the middle school curriculum. The rest of the course, the hard stuff, the probability and sampling distributions and inference, we did online, and we used a discussion board to have them try and communicate with each other. That did not go so well either. We made pretty big changes in Cohort 3. Those students we had for 10 days, for half a day. They were taking a pedagogy course, if I recall correctly, in the afternoons that was paired with ours. It was with Cohort 3 that we made the really big shift to focusing on concepts rather than calculation. And it was also with Cohort 3 that we incorporated a data analysis project. So to try and kind of synthesize the stuff we had been doing, we gave all of the teachers a data set. We really didn't tell them much other than what the data represented, and it was student achievement scores. And we asked them to come up with a research question they thought they could answer using that data, and then they just were set loose with that data. And then they presented the next day their research questions and what they discovered by playing around with their data. Cohorts 4 and 5 were back to 5 days, 8 hours a day. We continued and expanded that data analysis project. We incorporated more real data. We continued to emphasize concept over calculation. And we spent more time on good and bad graphs because a lot of the teachers, as I mentioned earlier, said that they taught these graphical displays in their middle school classrooms. So we spent more time talking about, well, what makes a good graph and what makes a bad graph. So we had a few things we used to assess the teachers. One was daily homework. They were assigned about 4 problems a night. And along with those kind of daily homework problems, which were pretty traditional kind of calculation-y problems, there were habits of mind problems. And habits of mind problems is one of the things that was constant across all of the math in the middle courses. These problems were designed to help the teachers kind of stretch statistically, to tackle problems they hadn't seen before, to see problems that were much more conceptual than calculation-y. So one of the examples we give in our JSC paper is we had the teachers read an excerpt from Freakonomics, which talked about cheating teachers on standardized exams. The excerpt gave them some sample student outcomes from 2 different teachers, and we asked the teachers to see if they could figure out, based on the student outcomes, which teacher they thought was cheating and what their reasoning was, and then to pretend that they could retest 120 classrooms and to design an experiment to try and catch the cheating teachers. As I've mentioned, we had a project with cohorts 3 and later. I think that project has continued to evolve. At this point now, when I taught a similar course most recently, I didn't provide them with a data set. I rather expected them to find a data set that they could use for their project. So all of that, the daily homework, the habits of mind problems, and the project went on during the week or 2 weeks of the course itself. At the end of the course, there was an end-of-course assignment that the teachers had roughly 2 weeks after the course was over to complete and submit. There was a set of problems that were very similar to the daily homeworks. There was a Super 7, which is, I think, something also that's kind of common across the math in the middle courses. We asked them to select 7 problems that they had worked over the course of the week and to kind of rewrite those up with some reflections on why they thought those 7 problems were so important, and also a lesson plan. The Super 7 was sometimes the most interesting thing to me to look at. I became, with later cohorts, I was always much more interested in their reflections and why they picked the 7 problems that they did than I was in their solution. The lesson plan was actually kind of the big part of the end-of-course assignment. We asked them to create a lesson plan that involved the active engagement of their students. So, grading. One of the reasons I really wanted to include the grading scale is because I have found this grading scale, anytime I'm teaching in-service teachers, so helpful. This is one that was provided to me at the beginning of all of this by the Math in the Middle leadership team. And it was really so helpful to kind of figure out, because we don't really have scores. You know, when the course goes over a week, we don't have numbers that we can add up and say, well, this person ended up with 94% or whatever. So we really think about achievement in terms of building leadership, in participating in class, in submitting things on time. And so this grading scale, I think, has been really, really helpful.
Okay, so as Erin mentioned, a big part of their end-of-course assignment was the lesson plan. So we have a couple of examples of some of the ones that were submitted. This first one was one that was done by somebody in Cohort 1, and we actually liked it so much that we incorporated it as an in-class activity in subsequent cohorts. So this one, she developed looking at differences in right hand and left hand, and in this one they were snapping, and so they had to snap for 30 seconds and count with one hand and then do it with their other hand, and we used this in class for paired t-test. Another example is one that a teacher uses in her own class, and she's actually still using it, and just took this picture for us that I have up next the other day, but hers has to do with least squares regression line and looking at the line of best fit. So the lesson plan started out with a bunch of practice problems and just discussion about how you would fit a line, and then they actually have this bulletin board with rubber bands so they can sort of visualize and understand how that line is being fit and how it's trying to minimize those vertical distances between each point and the line. So these are just a couple of really creative examples of lesson plans that some of the teachers have come up with and are actually still using in their classes. And that was one of the main points of the lesson plan as part of the assignment, is we wanted it to be something that they actually could use and would use, and not just something that they were creating as part of the course, but something that was more valuable for them.
So here are a few things that made this course challenging to teach. One of them is obviously the condensed time period. I think of all of the cohorts I've done, Cohort 3 is still probably my favorite, and I think it's because we had 2 weeks, half days. I think having that extra time for them to let content sink in really helped. One other thing that made this challenging was the background of the students. This was geared toward middle-level teachers, but because of the rural nature of a lot of Nebraska school districts, we had some teachers who were teaching grades 7, 12, so they were really high school teachers. We had some teachers who were teaching grades 3 through 6, so they were really predominantly elementary school teachers. And so those different backgrounds and experiences really led to differences in mathematical sophistication and how much confidence they had going into the course. We also had to balance what we thought needed to go into an intro stat class with what the teachers needed. And it was hard for us, I think, at times to realize that this course was going to look different than other intro stat courses we taught. And I think once we sort of got over that hurdle, and it seemed to me to be the big jump from cohorts 2 to 3, that we really started focusing more on concepts, focusing more on how this would actually be used in a middle school classroom rather than just teach it as a more traditional intro course. We were also not always prepared for the personality of the group. Some of the teachers were really not confident at all. I don't think any of us were prepared for tears over homework, which we observed in a couple of the cohorts. So I think we just weren't ready for that kind of personality. What made this course successful, I really think, is the instructional team. I was the lead instructor the first few cohorts round. I had 3 amazing graduate student instructors, all of whom are now faculty at other institutions, and all of whom have been either lead instructor or co-instructor for subsequent cohorts or offerings of the course. Another key part of our instructional team was a master teacher. The first 2 cohorts, our master teacher was a high school teacher from one of the local high schools who had experience with AP statistics. For subsequent offerings of the course, it was actually graduates from the course who were master teachers. And they were amazing. They helped us figure out like what teachers needed to know. They had much better ideas about dynamics in the middle school classroom. The master teacher was just incredibly invaluable. The other thing that made this course successful, I think, was that all of the instructors had a lot of experience with intro stat, and so we could kind of think on our feet, and when things weren't going well, we could adapt to try and meet the teacher's needs better. And like I said, we, especially after starting with cohorts 3, we really tailored the material to fit the audience we had. Okay, so where are we now? We have taught this through the first 4 cohorts in Lincoln that were funded by the Initial Math in the Middle project. There have been additional cohorts in Omaha and a few more around the state. This course now has its own number. 892 is kind of the generic special topics number for courses at Nebraska. It is now Stat 811T to designate it as a course for teachers. And it is part of the Nebraska Math and Science Summer Institute. So I think there are going to be 2 offerings of the course this summer. And those, the additional offerings have been taught by former grad students. They've been taught by master teachers. They've been taught by a lot of different people. And we also have a couple of spin-offs of this class. We have statistics for high school teachers, which was designed also for in-service teachers. We've offered that, I think, 3 times. And statistics for elementary teachers, which was designed for pre-service teachers, which has been offered once. And I think that's all we have, other than to note that this was funded by the National Science Foundation. Thanks.
Well, thank you, Erin and Kendra. So there has been one question that was typed in the questions box. If anyone else has questions, please feel free to type them in our questions area, or if you want to raise your hand, I can unmute you and you could talk to the speakers. So one of the questions here is, how did the check plus, check minus system I saw in the article feed into the grading scale, A plus, A, etc., you described?
That was one of the places I think we weren't expecting tiers for anything than a check plus. Mm-hmm. It honestly didn't factor in a whole lot because there were very few things, I think, other than check plus. Kendra may remember better than I do. Because the teachers also had the ability to go back and revise their work. Mm-hmm. So it didn't really play into it at all. Kendra, would you agree?
I think definitely at first it didn't play into it very much. The way that I've kind of used it in the last 2 times that I taught it, so as Erin mentioned, now we kind of have multiple people teaching this same class, is I've kind of broken it down for their final grade. Like I have the daily stuff, which is the check plus, check minus scale, so I kind of look and give them a score based on those checks, and then the other 3 pieces from the end of course assignment, I give them all equal weight. So the daily homework I don't give as much weight because, like Erin said, they can go back and revise and resubmit that, and we really want that to be more of a learning experience rather than, a big chunk of their grade. Mm-hmm.
There's another question here that's very interesting. Let me bring this up. I'm a mathematician pushing for our future teachers to take statistics. I've mostly convinced the stakeholders that such a course is necessary, but we are stuck as to who should teach it because our stats department has no teacher educators. Is there a role for me, a math teacher educator, in creating, designing, or assisting with such a course?
Oh, I think absolutely. Until I was approached about this course, I wasn't a teacher educator. I was the person in our department who was kind of most interested in teaching. And so that's why I was approached. I think if it weren't for this course, I wouldn't know anything about teacher education. And the first time through, we really relied heavily on our math ed colleagues to help us figure out how this course should work. I think the role of the statistician is kind of to push away from the calculation and into statistical thinking. And I think that's where the statisticians can be most helpful. Kendra?
Yes, I completely agree with you.
So we have another question. Why did you include confidence intervals and hypothesis tests in the middle school cohort? It seems not to fit with the 5 through 8 math curriculum expectations.
It doesn't, but it is in the educational research that they were having to read. And okay. That is why we focused, after we got to the place where we realized this wasn't all going to happen in a week, why we focused on interpretation rather than calculation, so that they could read those p-values, read those confidence intervals in the papers, and understand what they were saying.
Yeah, and I think one other thing that I'd like to add is that the program itself wasn't designed to only teach what the teachers are teaching. It was much more geared at giving them deeper knowledge of all of these concepts, and they also were taking calculus and number theory and cryptology, and those things certainly aren't apparent in middle level curriculum either. So it was there were more goals of the course and of the program in general than just to cover that content. Mm-hmm.
Here's a really interesting question. In a semester-long version of your course, say 2 hours per week for pre-service teachers, what changes would you make in your overall design?
I have taught a semester-long class for in-service teachers. It was for elementary teachers, actually with Jenny Green, one of the co-authors on this paper. And it was for elementary teachers, which made it very different. Their math background was not as strong. And we didn't cover a lot of the stuff we cover with the middle level teachers. We didn't cover regression. We didn't cover two-way tables. We talked a lot more about graphs and summarizing data numerically and graphically. And we did a lot with simulations. So we did p-values essentially on day 1 or day 2, but we did it with simulations. So how likely would you to be able to see this result, assuming the null hypothesis is really true? So over a semester, I think I would probably add a ton of simulation. I would add more lesson plans throughout the semester rather than just one at the end. With the elementary teachers, we had them do, I think, 3 lesson plans over the course of the semester, and they were peer-reviewed before they ever came to us, so they were reviewed multiple times by multiple readers. Yeah.
Are there any other questions from the audience before we start to wrap things up? We have a couple more minutes. So, Erin, you said that you have adapted this for high school teachers as well?
Yes.
What's different about the high school offering versus middle school?
We gear it a lot towards AP statistics, so we use a lot of AP questions for group exercises. We have them write rubrics to go along with old AP questions. We still have to stress statistical thinking, though, a lot, because the high school teachers were all pretty much math majors, and so they come in wanting to do probability. And so we have to take a step back and have them think a lot about what that probability means and how they would use it to make a decision. So one last question we have here. Why did you return to 5 days from 8 to 5 p.m. if it wasn't desirable in the beginning?
Because it fit in better with the rest of the math in the middle summer schedule.
Okay.
Yeah, it was. I would always pick 2 weeks.
And so they have other classes that they take in the summer as well, and so I think part of it is to fit more in. And then Erin likes the 2 weeks better. I personally like the 1 week better, so I think it just depends on who you are, which way you like to do it better.
Yeah. Well, thank you both so much for being here today and for sharing your work. And I see a lot of your co-authors are here as well attending, so thank you all for being here too. And thanks to everyone for being here this afternoon. I just quickly wanted to put in a plug for our next JSC webinar. This will take place at a special time. It'll be Wednesday, March 18th at 12:30 p.m. Eastern Time. And at that time, Larry Lesser and Amy Wagler from the University of Texas at El Paso will be presenting their paper. And the title of their talk will be "The Median Has a Balanced Representation Too." So thank you all, and I hope you have a good afternoon, and we hope to see you back in March.